I will move to point number 2. I will group the second, the third, and the fourth row in one example or one discussion. So mathematics is based on deduction only. Mathematics collects data, and this data is abstract, and it uses logical rigor, versus physics that uses deduction plus induction plus other forms of reasoning. It collects observation instead of data, and those observations are concrete physical entities, and it sometimes guesses the answer, so no logical rigor whatsoever is necessary. I'm going to combine those three into one discussion. Slide 10. Consider the first 300 prime numbers. They are on your slide, and I have included the name of the sequence here. If you want to refer to larger numbers, you can go click and watch this for yourself. These are the first 300 primes. If you look there, you will see some things colored in yellow. Okay, you have no idea what this is, huh? This is just a list of objects, and you have these things colored in yellow, and then you look here and you say, oh look, between 3 and 5 there's a -2, and between 5 and 7 there's a -2, and between 11 and 13 there's 2, and 17, 19 there's 2, 29, 31 there's 2, 51, 59, 61 there's 2, 107, 109 there's 2, and so on and so forth. These pairs keep occurring. We call them twin primes. Essentially primes that are neighbors. They are twins, they call them, because they have a difference of 2. And guess what? There is no proof. Is there any valid proof of this? No. Anywhere? No. Any suggestion? No. Any let's say submission of a proof. So someone thinks that they have a proof and they've submitted it, and we are reviewing it. So that to check for validity or not is a different issue, right? Oh, we have, just like Andrew Wiles, we have a suggestion of a proof, and then we're gonna review it, see if we agree or not. No, there's nothing like that. This is just a twin prime conjecture, we call it. A conjecture is a result in mathematics that looks to be the case. Okay? Point number 1, we said mathematics does not collect observation. Can you tell me exactly what this is? What is it that we've done now? This is exactly what observation is. You have a list in front of you, and you're looking at this list, and instead of just looking at the list, blindly, oh, it's a list of increasing numbers, that's data, right? Oh, you're looking, oh, I'm observing, I don't want to say meaning, but I'm observing relations between objects on this list. This is exactly what a physicist would do if they're observing something new, or a chemist, or a biologist, or it's a new phenomenon. This is the list of primes, and I just paid attention. It's been in front of me for decades. It's been in front of me for millennia. The solar system existed ever since we did, and even way before us. But we just started, in history terms, right? Yesterday night we started discovering what's in the solar system, relatively speaking. So this list of primes was in front of us as well all the entire time. But then at some point, people paid attention that, oh, look, there's this 2 difference between these two. And it looks like it goes on forever, as far as we can reach and calculate. So the claim that mathematics does not do observation, I think, is misleading. This is exactly observation and the conjecture, just like the scientist does. Observation, hypothesis, and then you go test it. Exactly the same thing. We will talk about the test later on. Let's take them step by step here. The claim that says mathematics does not collect observation is mistaken. At least some mathematics. Some other mathematics could not use that, right? But some mathematics clearly does. If you want to call the twin prime conjecture not mathematics, I have bad news for you. There's tons and tons of those examples. The Goldbach conjecture is one of those. The Fermat's-Last theorem we just saw is one of those. You can go on forever. So if you want to discard all of those as not mathematics, then this is up to you, but I'm not of that opinion, and I don't think you will have a lot of friends taking that side, calling everything that only has proofs that were validated by the mathematical community as math, and everything else is just not math. So what does the mathematician do? They do nothing until they have a valid proof that everybody agrees to. No, I don't think people will agree to this. Just like people who do science are always on the edge of the discovery. It's not always, me explaining whatever people have discovered. The real scientists, what the scientific method is really needed for, is not for the established things, it's for the unestablished thing, it's for the edge. And this is exactly what we need, methods of discovery in mathematics, quote unquote discovery. Because I say discovery, we haven't shown the entire argument for it yet. This is exactly the same exercise. This is point number one. When you say science guesses the answer, that Feynman says, oh, it's enough to guess the answer, but mathematics never does. This is exactly what we did. We're guessing the answer here. What did Andrew Wiles did? He guessed the answer. What did Euclid did? He drew some circles, he drew some triangles, and he says, you know what, this looks like the case. Let me try to prove it. This is guessing. This is the same exercise, absolutely the same exercise. There's no difference between this kind of guessing and the other kind of guessing. Number three, when they say mathematics is abstract, and then the other observations is concrete. What's abstract about this observation that we've done? This is a very physical list in front of me of objects, and those objects have properties, and I am remarking their relationships. I'm remarking those properties. In what sense is this different from observing something fall down in the physical world? There are two objects, the planet Earth, right, if you're going to take the Newtonian sense, and then another object, and these two objects are interacting. They have a property that they attract each other, and I'm observing that property to reveal its shape and, let's say, its details. I'm doing the exact same thing here. I have objects, and these objects have relations, and I'm kind of observing, making a guess about what the real details of those relationships are. In what sense is this abstract? Nothing abstract about this at all. Just taking this, yes.
I'm trying to think. So I just talking about the twin prime conjecture, right? You look at it, you say, okay, I'm going to guess that they go on forever. And that is very much like physics. I'm going to guess that masses attract masses, and with this formula. I think, can I just thought, yeah, is that a fair analogy?
In my mind, it's the same kind of activity, right? They might differ in the method used. They might differ in the observation criteria that you use, which is something we're going to get to. But for now, I'm just asking the abstract business. I'm just asking whether the guesses happen or not, and I'm asking about the deduction. That's what I'm asking about.
No, I think it's really a good example. It makes me appreciate that there are things in math that we haven't proved. We guess. We actually guess at a relationship that we can express that we can't prove, and that's exactly like what we do in science. But I wonder about this possible difference in that, for instance, in the case of the twin prime conjecture, I don't see any entailments of that I can use to falsify it, other than the fact that you'll never see twin primes. And in science, you come up with a guess. That guess has all sorts of entailments beyond just, oh, but here's a mass that doesn't, if I see masses attract, or I think that's what's going on, I could observe a mass not attracting another mass. But there's lots of other ways of falsifying it because the entailments go on. And I don't know if there's a difference. Maybe you can convince me.
There's no difference. It's just that you and I don't know enough math. Sorry to jump in here immediately, but
so what do you mean? So you mean there are entailments?
What do I mean? I mean this twin prime conjecture. Yeah. I'm gonna make it easy. When I say I want a proof of the twin prime conjecture, what is it that we're looking for? I'm looking for a list of statements that, linked with derivation rules, are going to get me to the twin prime conjecture. This is what I'm looking for. These theorems are already the ones I'm using. Some of them are axioms, so we all agree on. Most of them, actually, at this point, instead, the vast majority of them should be discovered theorems. And I'm using the word discovered more and more now. So now when you say, I don't see the relation between the twin prime conjecture and other theorems to see whether there are entailments of this or not, you and I don't know enough math to say this. I can tell you immediately that this twin prime conjecture is linked to the Riemann hypothesis. It's linked to the Goldbach's conjecture. It's linked to all these things that we still are trying to discover. So proving one of them can make easier proving others, and disproving one of them can make it a lot easier to disprove others. And this is exactly how Fermat's theorem was proved 400 years after its conjecture.
Yeah, okay, so that's right. So I guess I see possible linkages, entailments, things that you could disprove something else and therefore disprove this thing. But as you said at the beginning, what you're looking for is a proof of the twin prime conjecture, and that would be like looking for a proof that masses attract other masses. Nobody thinks that's possible.
Or a proof by contradiction. Unless you are an intuitionist. If you remember last episode when we said there's a camp that refuses the negation of negation is not the thing itself. So they refuse the excluded middle rule, etc. But if you are a classic logicist, we accept at least the majority of them. They accept the middle third removed rule. So that now, if either I can find a direct constructive proof of the conjecture, like a direct, either a constructive proof or an entailment of that conjecture by other theorems, or I can say, let's assume this doesn't work, and then find the contradiction you're asking about. So when someone finds that contradiction, then they have proved that this is not the case, or they have proved that it is the case by proving the negation wrong. Does that make sense?
Well, I'm not sure I followed all of that, and maybe just tell me whether you a simpler way to address this. In the case of the twin prime conjecture, it's completely conceivable that you could prove that that's true, and people would agree that the proof is valid and all that kind of stuff. It's inconceivable, I think, that you could prove that masses attract other masses.
The word proof, I only understand in one meaning, which is entailing from given axioms. Now, I can do it in two ways. I can cheat and say masses attract other masses as an axiom, which is kind of what physics does. I'm not sure. You correct me. Is it not very analogous to when you say, oh, there's 4 fundamental forces in the universe, and gravity, at least in the classical sense, used to be one of them? So you can't ask me why is it that a positive charge attracts negative charge. It just does. I just use that fact to explain everything in the universe. You can't ask me why masses attract. This is the property of a mass. This is exactly what we understand mass as. So there's that thing. Or I can start from other givens, which is kind of what, if you remember back in the day, I sent you a paper of axiomatization of relativity, special and general. So they started from other givens and then they entailed all the others. So this is the sense of proof I understand. When you say it's impossible to prove something, at least in the banal, naive sense, I can include it as an axiom, and that's enough proof for me. You know what I mean?
I wanted to answer your question from the words of Leonard Susskind, who recently said quite simply that string theory is not a description of the universe we live in. Now, I think that a description of the universe we live in is the proper definition of physics. And string theory is certainly math, but it is not physics, according to Leonard Susskind.
Just for the record, I agree with that.
I have no horses. I have no horses in that race. I agree too. Whatever you want to call physics or not, again, we're not about the demarcation here. Although it is very essential part of the discussion, I cannot tackle everything at the same time. All I'm saying is there more similar? Let me not say more. Now people will catch me. They say he's going. Are they the same exercise? So when I'm doing math on a piece of paper and when I'm doing physics, exploring the universe, are they the same exercise qualitatively in logic, in shape, in practice, or is there more in physics than there is in math? And this is what we're discovering here. And I give you back the table of what we have discussed so far. So people usually claim that mathematics is certain. Turns out it's not the case. People usually claim that mathematics only does deduction. So no induction, no abduction, no observation, no nothing, no collecting data, no using guessing. We only use logical rigor in mathematics. Turns out to be absolutely not the case. And we used examples from the history of mathematics, modern and old, to show that these things continue to happen right in front of us. As long as you are, you're not willing to claim that everything that doesn't have is not mathematical activity, you will not have friends with that opinion. I cannot argue against you. You are, but this is very extreme. I don't think that mathematicians who are working in their research now are not mathematicians simply because they're trying to find a proof. I think this is exactly where the real hard mathematics happens, not in my classroom when I'm teaching, beginners. As far as we can tell, those presumptions about mathematics are kind of looking shaky, let me say. In my mind, they have already fallen, but I'm hoping that in your minds, they're kind of starting to look shakier than they were before. Any last thing about these 2 points before we move on? I still have a couple, and then we can open a general discussion if you like. I want to apologize to Wissam. I wasn't looking on chat a little bit ago, like 30 minutes ago. I'm doing a lot of things, so please bear with me. He says the tarot card reader observes their cards. You are right that mathematicians also observe things, but we still lack an argument for equating these things. Absolutely right. Just based on that one point, because the observation happens here and there, doesn't mean that they are exactly the same domain. We are running through the phases of, let's say, similarity one after the other, and they're gonna start falling one after the other. The differences, and they're gonna start to fall one after the other, and hopefully by the end, I will get to every point you have in mind. And if I don't, then we can